Hello, my name is Adam Stifter and I'm a University of St. Thomas student in the Geography and Environmental Studies department. Today I'm going to walk you through a short history of cholera in London. Cholera at the time was a relatively new disease, the initial outbreaks beginning in the 1830s and continuing on up through the 1850s. Little was known about cholera, it being so new to the island, but one of the most important unknowns was how it was spread. There were many theories during this time, and Edwin Chadwick at the right believed that cholera could be spread through bad air and bad smells. This particular theory gained a lot of popularity because it was simple and could be easily understood. John Snow, one of the many doctors at the time, had a different idea of how cholera was spread. In 1813, John Snow was born, and by 1831 he was apprenticing as an MD during the first cholera epidemic. By 1849, he, like many others, published a paper hypothesizing how cholera was spread. John Snow thought it was spread through water. His paper went mostly unnoticed in the slew of papers that were written at that time hypothesizing how cholera was spread, but in 1854 he got the chance to really explore that as the next cholera epidemic was breaking out. He narrowed down the source area to an area known as the Golden Square, a particular area that was known for its polluted water. Through that, he was able to explore his hypothesis that cholera was waterborne. My goal in this particular exercise was to replicate John Snow's research and find spatial correlations between the data and his conclusions using modern-day GIS tools. On the slide now is a map of London 1854, specifically the area known as the Golden Square. Here's the same map with cholera deaths. Each black dot represents one death. You can see it's concentrated in this rather small area. And thanks to the point density tool, we can see where these deaths are really concentrated. Keep this area in mind. Here's the same unmodified map of the Golden Square. While we did have one correlation through the previous tool, two correlations are better than one when it comes to scientific research. Through the mean center tool, I was able to determine the mean center of deaths as marked by the red X. Now, using the standard deviational ellipse tool, we again see the specific area of the Golden Square highlighted. Here we have the standard deviational ellipse and the mean center overlain on the map. Now we have our second correlation, and while two correlations is good enough, three correlations are better. So again, we start back at the 1854 grayscale. Now we can take a look at the water pumps. These are the public water pumps that were active at the time John Snow was collecting his data and the cholera was running rampant. I then used the Create Tyson Polygons tool with pump data as my point sources in order to establish general trade areas, areas that people would be more likely to use, say, one well over the other. Then, using the output of those trade areas and the density of cholera deaths into the zonal statistics tool, I was able to find the mean number of deaths by trade area. As you can see, this one particular trade area rather, seems to be experiencing the greatest number of deaths. And now, with the mean center of deaths and the standard deviational ellipse overlaying, you can see we have a true correlation here. Snow's conclusion was that this particular water pump, the Broad Street pump, was the point source for these infections. With the help of modern GIS tools, I have confirmed that there is indeed spatial evidence suggesting that the Broad Street water pump was the point source for the cholera outbreak. John Snow came to the same conclusion, and he and others approached the city, suggesting that the pump lever be removed. And so it was. Shortly thereafter, the cholera outbreak ceased, and that was the last large-scale cholera outbreak for the City of London. As we come to the conclusion of this slideshow, you may be asking yourself, why is all this important? Well, Snow's work helped to show that cholera is a waterborne illness and show that germs exist and can cause disease. Additionally, Snow's work promoted better sanitation and aided greatly in the creation of the field of study known as epidemiology. How is this relevant today? Well, the same information gathering techniques can still be used and analyzed and help determine potential sources for outbreaks and the paths through which an outbreak may spread. Thank you very much.